What's up, everybody? In this question, we have to factor these two expressions. So let's start off with this one, 125x to the 4 minus x. First thing you always want to check with factoring, can you take any common terms out? Any constants, any variables? Well, we can't take out any constants, but notice that we can take out an x variable, right? So we take out the lowest degree possible, which is x to the 1. So in brackets, we'd be left with 125 x to the 3 minus 1, right? So we just took this x out, so we divided each of these terms by x, and this is what we're left with in the brackets there. Okay, so now, can you factor this further? Well, notice that this here is a difference of cubes. And what is the general difference of cubes formula? So we got a cubed minus b cubed, and that's going to equal a minus b, a squared plus ab plus b squared. All right, so taking this, writing it just below it, what is the a value going to be? Well, a cubed is equal to 125 x to the 3. So that means a, if we take the third root of everything, if we take the third root of 125, so we take 125 to the power of 1 over 3, that would give us 5. And then the third root of x cubed is just x. So this a value, 5x, we're going to plug into this function here. So what's the b value going to be? Well, b cubed, notice how it's equal to 1. So if we take the third root of 1, b is just 1. So we got to take this a value, this b value, plug it into this expression, into this equation for the difference of cubes. So in brackets, we'd have a minus b, 5x minus 1. Here we'll have 5x squared. Now you got to be careful, this 5x has to be in brackets, right? A lot of students, what they'll do is they'll just put 5x squared without the brackets. However, that entire a term has to be squared. And then we're going to add a times b, so 5x times 1. So notice how I'm always putting brackets whenever I'm inputting in this bracket any a or b values. And then plus b squared plus 1 squared, close bracket. So simplifying this further, 5x minus 1, we can't simplify any further, so this bracket stays as is. Now 5x in brackets squared, that's going to be like 5 squared times x squared. So it's going to be 25x squared. All right, so you got to take that coefficient, that constant, to the power of 2 as well. 5x times 1 is just 5x. And then 1 squared is just 1. And then this bracket, we can't factor any further. So we basically took this 125x cubed minus 1, and we factored it into this. So bringing that over here, this bracket, we would just rewrite 5x minus 1, 25x squared plus 5x plus 1. Right? So we took this difference of cubes and we factored it on the side. The most important thing is figuring out what is your a value to plug into this equation. A value, b value, once you have those, make sure that you're always putting brackets, especially in the second bracket here. And then you end up getting that factored difference of cubes, and then you could bring it back here. So this factors into this here. 3 terms, and we can't factor any more. All right, now what about this second term here? 27x to the 5 plus x squared. Well, again, you first check if you could take out any constants, any variables. Whenever you're factoring, that's always the first thing to look for. Can't take out any constants, but we can take out a x squared variable, right? And if we take out x squared from these two terms, 27x to the 5 divided by x squared would give us 27x to the 3. And then x squared divided by x squared would just be 1. So that is the first step. in our factoring. So we have this expression, we split it up into two factors, but with factoring, you always want to split it up into as many factors as possible. So this x squared, we can't do anything else with it. Can we do anything with this 27x cubed plus 1? Well, we can. Notice how this is a sum of cubes. So here we were dealing with a difference of cubes. This here is going to be a sum of cubes. And if you remember, sum of cubes formula is a cubed plus b cubed equals a plus b. Let me erase this here. A squared minus ab plus b squared. All right, so we have 27x cubed plus 1. So we have to figure out what's the a value going to be, what's the b value going to be that we can plug into this formula. Well, from here, we can tell that what? A cubed equals 27x cubed, right? Both of these equal. So if we take the third root of both sides, a has to equal, third root of 27 is 3. Third root of x cubed is just x. And then, so that's our a value. And then b cubed is equal to 1, so it's easy to tell that b is just going to equal 1. So now we could take this a value, this b value, and we can plug it into this formula. So we'll have a plus b, so 3x plus 1. Let me put the equal sign here. And then a squared, so again, we have to take that a, make sure you put it in brackets, minus the a value times the b value plus the b value squared. And then simplifying this, we'd have 3x plus 1. 3x in brackets squared, we have to square the 3 as well, so that would give us 9x squared. 3x times 1 is negative 3x, plus 1 squared is just 1 there. All right, so this factors into this, and we can't factor that second bracket anymore. So bringing this up here, taking this 27x cubed plus 1, and then we can just rewrite this here. 3x plus 1, 9x squared minus 3x plus 1. And we can't factor any further. So we took this expression and factored it into 3 separate terms. All right, so not too bad. Just noticing you're dealing with a difference of cubes, sum of cubes. I would highly recommend you go back to that chapter and do like more complex sum and difference of cubes. So what you want to practice is basically getting this a value and this b value. And sometimes it could be a lot more complex. So let's say instead of x cubed, this was maybe x to the 6. Right? So then it becomes a little bit more complex because then we have to take the third root of x to the 6. So multiplying it by 1 over 3, that would give us x squared. So now we would have like an x squared, 3x squared for the a, if this was 27x to the 6 instead. So just things like that. And sometimes you could also have fractions, taking the third root of fractions. So let's say you had a fraction like, I don't know, let's say 125 over, let's say 64. And you have to find the third root of that. Well, the third root of that function, or that fraction rather, third root of the numerator is going to be 5, and then the third root of the denominator is going to be 4. So if this was like 125, 125 over 64x to the cube, then your a value would be 5 over 4x, right? So let me just go back to what we had originally. All right, so make sure, basically bottom line, make sure you're going back to that sum and difference of cubes and trying out a bunch of different questions, because you don't know what's going to come up on your test. They can have something fairly simple like this, or they can have something more complex where maybe these exponents are going to be higher than 3. Maybe they'll be like 6 or 9. And you may also have fractions you have to deal with.